All right, today we are going to be doing the notes on the Earth's interior. We've done lots of experiments and online simulations and activities that have to do with the Earth's interior. And I just want to verify that we know what's happening and that we can make connections between all the activities that we've done. So here you can see the animation shows that there is the Earth, and the Earth has multiple layers. There's the crust, the mantle, the outer core, and the inner core. That's my phone, apologies. It's very much like a peach. A peach has the outside skin. It has the actual peach part, which is like the mantle. The outside skin would be like the crust. And then the hard center would be somewhat like the core of the Earth. Now the difference is there's not a liquid center before you get to the hard shell of the seed. In order to study this, we need geologists, and geologist is someone who studies geology. And geology is the study of the planet Earth, or the study of rocks, because the Earth is a giant rock. A geologist is a scientist who studies the forces that make and shape the planet Earth. So anything to do with rocks and how they have formed on the planet Earth is what a geologist does. A geologist also studies the chemical and physical properties of rock, and they study the processes that create Earth's features and search for clues about Earth's history. So you can see how we're looking at Earth's history and how it was formed, and that's who a geologist is. So we're all kind of being geologists through this process. So surface changes include forces beneath the Earth's surface that are constantly changing the appearance. This could include constructive forces that shape the surface by building up mountains and land masses. Here you can see there's a lava flow. This is in Hawaii, and lava is coming out of the mountain. And this is hitting the water, and once the lava hits the water, that rock freezes and becomes new land. So that is a constructive force. It's building new land. This could also include mountains. This isn't obviously an example of a mountain, but mountains can be also formed through a constructive force. A destructive force, again, this is within the name, is destructive forces are slowly wearing away mountains and every other feature on the surface. So it's that wearing away of the rock. So the top left picture, I'm going to guess that they did not build this house on the edge of a cliff. They put that house on a normal piece of land, and over time it has been worn away by the beach below. So that rock has moved down the hill and down the cliff, and has now moved to the beach and it's turned into sand over time. Now you can see the bottom right, the GIF there, that you can see some destructive forces that's happening in real time. And that was due to water eroding away the bottom. And once the bottom gave way, it eroded away the rest. At the bottom left, you can see that there is a sand carried by wind has been eroding away the side of that mountain, and that landscape has been changed. Talking about young Earth, density has caused the heavier elements like iron and nickel, which is what the inner and outer core is made out of, in the melted rock to sink to the center of the Earth. So we had all these different elements, and the heavier items sink to the bottom. So this is like having a piece of metal and it sinks to the bottom. You can see the animation on the right-hand side, how it's sinking. If it has more density, it's going to sink. The less dense elements, like a piece of wood or some plastics, it's going to float to the surface. So some examples are like Captain Jack Sparrow. His boat was filling up with water, was becoming less dense, and was sinking in that movie. Another example would be like this lizard creature. It's becoming less dense because there is a force that's pulling it upward, so it is less dense. Just a couple of silly examples to help you understand that. Seismic waves. There are two different types of seismic waves that we will discuss on this page. There are S waves and P waves. This is just a brief overview. We're going to do more seismic waves in the next set of notes. But just for this quiz, you're going to need to understand that this is how we know what is on the inside of the Earth. Seismic waves are used to determine the Earth's interior because we cannot get through the crust. So we have to figure out, well, how are we going to know what is on the inside? Well, we look at waves and how they move through the Earth. These seismic waves are created, these powerful waves are created by earthquakes. Okay. So the P waves travel through the outer core and the inner core. So you can see the P waves on the top right here. They can travel through all the layers. Doesn't matter if it's solid or liquid. They're very fast. The P stands for primary. So they're primary waves. They're very fast moving. They travel through liquids and solids. It's very important. Primary waves travel through everything. Whereas S waves, they are very slow moving. They are not as fast as the primary waves because the S stands for secondary waves. They're slow moving and they can only travel through solids. So as you can see, it bounces off of the outer core. The outer core, why is that important? Because the outer core is liquid. Okay, so it bounces off or stops at the outer core. So it cannot travel through the outer core because the outer core is liquid. So that's how we know what's on the inside. So if we're traveling through the Earth, we have the crust, the mantle, the outer core, and the inner core. Those are our four main layers we're going to be talking about. And those are the layers based off of the chemical composition. As you're getting deeper and deeper, the temperature increases and also the pressure increases. So just like when you're diving into a pool, you can feel your ears popping because that pressure of all that water is pushing on your eardrums. Sorry, my phone's going off. Someone's at my front door apparently. So as the pressure increases, the temperature also increases. So the deeper the layer, the hotter the layer. The deeper the layer, the more pressure. So the layer with the most density and the highest temperature is the inner core. The layer with the lowest density and the lowest temperature is the crust. Here's just some other examples of different planets and how they have a crust, mantle, and core. So you can pause that and take a look at the differences and how Earth varies from other planets. We use different types of waves to see what's on the inside of other planets. All right, so there is heat in the core, and why is it hot in the core? It's so deep down there. How does it get so hot? Well, this is left over from the formation of the Earth. A lot of friction has happened because the Earth is spinning. The inner core and the outer core are still spinning. The denser core materials have sunk to the center of the planet because of gravity. All that gravity has drawn it towards the center, and since it did that, it causes some friction, and that friction then causes heat. So if you take your hands and you're rubbing your hands together, it causes some heat. Imagine all the rocks are being pulled down. There's a lot of heat still left over from that happening, and they're still spinning, so it causes more heat. And also there's radioactive elements that are down there that are also causing that heat to occur. Now, I just said that the inner core and the outer core are spinning. Well, that also has a different effect besides just friction. There are convection currents in the outer core and the mantle too, but the outer core I want you to tune into right now. The outer core creates electric currents because of the friction. So if you have this metal that's spinning around, it's going to cause friction, and then that friction then will cause a magnetic force. And that electric current will create a magnetic field. And then if we have a magnetic field, as you can see, there's a magnetic field around the Earth that will create a protective layer around the Earth to protect us from harmful rays from the sun. You may have seen the effect of the magnetic field through up north, like the northern lights. You may have seen those. They happen in north and south poles. So you can see those sometimes where it's really thin to see. All right, that is the basic concepts of this first quiz of the year. And that's all, folks.